have a quick overview of all the equations coming under arithmetic progression, and it will help you in solving the problem. The general form of an AP is A plus D, A plus 2D, A plus 3D and so on. Then we have seen the equation for common difference D. D is equal to AK plus 1 minus AK. Next equation for the nth term of AP in terms of first term A and common difference D is given by An is equal to A plus n minus 1 into D. Also, we discuss another equation for the nth term of an AP, which is the difference between Sn and Sn minus 1. An is equal to Sn minus Sn minus 1, where Sn is the sum to first n terms and Sn minus 1 is equal to sum to first n minus 1 terms. Then we have seen the equation for the sum of first n terms of the AP in terms of first term and the common difference, that is S is equal to n by 2 into 2A plus n minus 1 into D. Then in terms of first term and the last term, the sum equation is equal to n by 2 into A plus L. Now let us move on to the problem. Problem number 1. An arithmetic progression consists of 50 terms, of which third term is 12 and the last term is 106. Find the 29th term. Solution. We know that An is equal to A plus n minus 1 into D, given the third term is equal to 12. So, A3 is equal to A plus 3 minus 1 into D, that is 12 is equal to A plus 2D. Bringing 2D to the other side, we get A is equal to 12 minus 2D. Mark it as equation number 1. Also given last term is equal to 106. Last term is equal to 50th term, that is our A50 is equal to 106. So A50 is equal to A plus 50 minus 1 into D, or 106 is equal to A plus 49D. Bringing 49D to the other side, we get A is equal to 106 minus 49D. Mark it as equation number 2. Now from equation number 1 and equation number 2, we get 12 minus 2D is equal to 106 minus 49D, or bringing the like terms together, minus 2D plus 49D is equal to 106 minus 12. So on solving, we get 47D is equal to 94, or D is equal to 94 by 47, which is equal to 2. Now put this value of D in equation number 1. We get A is equal to 12 minus 2D, that is equal to 12 minus 2 into 2, which is equal to 12 minus 4, and we get A as 8. Now we need to find the 29th term, that is A29. Now An is equal to A plus n minus 1 into D. So put the values of A is equal to 8, D equal to 2 and n equal to 29 in the equation. We get A29 is equal to 8 plus 29 minus 1 into 2, which is equal to 8 plus 28 into 2, which is equal to 8 plus 56, and we get the answer as 64. So hence we can say the 29th term, that is A29, is equal to 64. Let's see the next problem. Find the 20th term from the last term of the AP 3, 8, 13 up to 253. Let's see the solution. Given AP series 3, 8, 13 up to 253. In order to find the 20th term from the last term, we consider the sequence as follows: 253, 248, 243, 13, 8, 3. Now what is the A here? A is equal to 253. What is the D? D is equal to 248 minus 253, which is equal to minus 5. What is the value of n? N is equal to 20. So A20 is equal to A plus n minus 1 into D, which is equal to 253 plus 20 minus 1 into minus 5, which is equal to 253 plus 19 into minus 5. On solving, we get 253 minus 95 as 158. So the 20th term from the last term is 158. Now problem number 3. Two APs have the same common difference. The difference between their 100th term is 100. What is the difference between their 1000th terms? Solution. We know that an is equal to a plus n minus 1 into t. So, 100th term will be a 100 is equal to a plus 100 minus 1 into t. That is a 100 is equal to a plus 99t. So, 100th term of first AP is equal to a plus 99t. Let second AP be denoted as Bn is equal to b plus n minus 1 into d. B100 is equal to b plus 100 minus 1 into d, or B100 is equal to b plus 99d. So, 100th term of second AP is equal to b plus 99d. And as for the question, it is given difference between their 100th term is 100. Therefore, A100 minus B100 is equal to 100. Substituting the value, a plus 99d minus b plus 99d is equal to 100. Again, rearranging, a plus 99d minus b minus 99d is equal to 100. A minus b plus 99d minus 99d is equal to 100. Again, on solving, we get a minus b is equal to 100. Mark it as equation number 1. Now, we need to find difference between their 1000th terms, that is equal to a 1000 minus b 1000. We can write it as a plus 1000 minus 1 into d minus b plus 1000 minus 1 into d, which is nothing but a plus 999d minus b plus 999d. Opening the brackets, we get a plus 999d minus b minus 999d. On rearranging, we get it as a minus b. Putting this value from equation 1, we get a minus b is equal to 100. So, the difference between their 100th terms is 100. Next problem. The first and the last term of an AP are 70 and 350 respectively. If the common difference is 9, how many terms are there and what is their sum? Solution. Given a is equal to 17, then the given data L, that is L is equal to last term is equal to 350, then what is D? D is equal to 9. We need to find the number of terms, that is n, and their sum. Since we know the last term, we can use the formula S is equal to n by 2 into a plus L. Substituting the value n by 2 into 17 plus 350, and we get 367 into n by 2. Mark it as equation number 1. Also, as per the other formula, S is equal to n by 2 into 2a plus n minus 1 into d. Substitute the values of a and d. N by 2 into 2 into 17 plus n minus 1 into 9. Now, opening the bracket, we get n by 2 into 34 plus 9n minus 9, which is equal to n by 2 into 25 plus 9n. Mark it as equation number 2. Now, equate equations 1 and 2, we get 367 into n by 2 is equal to n by 2 into 25 plus 9n. Cancelling n by 2 on both sides, we get 367 is equal to 25 plus 9n, or 367 minus 25 is equal to 9n. On solving, we get n is equal to 342 divided by 9, or n is equal to 38. Now, we need to find the sum. Now, put this value of n in equation number 1 and see. Sum is equal to 367 into n by 2. So, 367 into 38 by 2, we get 367 into 9, 19. On solving, we get 6973. So, the number of terms is 38 and the sum we got it as 6973. Now, fifth problem. If the sum of first n terms of an AP is 4n minus n square, what is the first term? That is S1. Now, what is the sum of first two terms? What is the second term? Similarly, find the third, the 10th and the nth terms. Let's move on to the solution. Given Sn is equal to 4n minus n square. Now, taking n is equal to 1, S1 is equal to 4 into 1 minus 1 square, which is equal to 4 minus 1 is equal to 3. So, sum of first term of AP, that is S1 is 3, but the sum of the first term will be the first term. So, first term is equal to A equal to 3. Now, taking n equal to 2 in Sn, S2 is equal to 4 into 2 minus 2 square, which is equal to 8 minus 4 is equal to 4. Therefore, sum of first two terms, that is S2, we got it as 4. Now, we need to find A2, A3, A10 and AN. Now, use this equation AN is equal to Sn minus 1, finding the second term. A2 is equal to S2 minus S1, A2 is equal to, substituting the value, we get 4 minus 3 is equal to 1. Now, find the third term. A3 is equal to S3 minus S2. We don't know S3, so we need to find S3. For that, put n equal to 3 in Sn is equal to 4n minus n square. What we get? S3 is equal to 4 into 3 minus 3 square, which is equal to 12 minus 9, and we get it as 3. So, we got S3 equal to 3 and S2 is equal to 4. Now, find A3. What is A3? A3 is equal to 3 minus 4, which is equal to minus 1. Now, go for finding the 10th term. So, A10 is equal to S10 minus S9. Now, find S10, put n equal to 10 in Sn is equal to 4n minus n square. We get S10 is equal to 4 into 10 minus 10 square, which is equal to 40 minus 100, and we get it as minus 60. Now, find Sn. For that, put n equal to 9 in the equation. Sn is equal to 4n minus n square. We get S9 is equal to 4 into 9 minus 9 square, which is equal to 36 minus 81, and we get it as minus 45. So, we got S10 is equal to minus 60 and S9 is equal to minus 45. Now, we can find A10. A10 is equal to minus 60 minus 45. So, opening the bracket, we get minus 60 plus 45, and the value of A10 comes as minus 15. Now, we need to find the nth term. An is equal to Sn minus Sn minus 1. We know Sn is equal to 4n minus n square, but we need to find Sn minus 1. For that, put n is equal to n minus 1 in Sn is equal to 4n minus n square equation. So, Sn minus 1 is equal to 4 into n minus 1 minus n minus 1 square. Now, opening the bracket and expanding, we get 4n minus 4 minus bracket open n square minus 2n plus 1. Now, again we can write it as 4n minus 4 minus n square plus 2n minus 1. And rearranging, we get minus n square plus 6n minus 5. So, Sn is equal to 4n minus n square and Sn minus 1 is equal to minus n square plus 6n minus 5. So, what is the value of An? An is equal to 4n minus n square minus of minus n square plus 6n minus 5, which is equal to 4n minus n square plus n square minus 6n plus 5. And rearranging, we get the value of An as minus 2n plus 5 or 5 minus 2n. So, in short, we can write again S1 is equal to, we got it as A equal to 3, S2 is equal to 4, A2 is equal to 1, A3 is equal to minus 1, A10 is equal to minus 15, and An we got it as 5 minus 2n.